Hello and welcome to Answer Everywhere. Today we are taking a look at JQ, which is a JSON processor is what they call it here. It's a little bit like SED, a stream editor for JSON. And you have probably used it. And I think it's relatively small. And since I'm not feeling well lately, I thought it'd be fun to look at something that's small and also pretty universally used and universally loved. All right, so I think it looks like maybe all the things are in source. Tests might be mildly interesting, but we will skip tests for now. And we have deck number, deck, maybe decimal, and then a bunch of C headers, a .y file, which I'm going to guess is maybe yak, probably something, since it's parser.y, I'm going to guess it's probably something yak-like. So let's look at the parser for sure. We have some opcodes. Lock file. Lock file might be location. We will look at linker first. Libm. Lexer for sure. And Lexer header. JV thread. I don't know what JV is. And I guess let's look at the JV thread header and JV parse. JSON vector maybe? D2A is going to be, I guess, I always forget. I guess A is ASCII, like decimal to string, I think is what it stands for. Whatever JV aux is, some allocation looking stuff. JV.h has its own file. Let's look at JV just to see if we can figure out what it is. JV ref count. Invalid has message. I don't know, but what is it? JV. JSON. I don't know. And then we have an execution stack. Compiler. I guess viewing this as a programming language, that may be what compile is about. Some bytecode stuff, which I'm going to guess is not the most coolest. And then we have this deck number. And we have decimal 32, decimal 64, and some example.c's. Convert the first two argument words to deck number and add them together. Okay. Decimal number library demonstration program, the IBM Corporation, 2001 to 2007. I'm wondering if this is something that is basically vendored. Deck number. The deck number library. The deck number ANSI implementation of general decimal arithmetic. It is also available in PDF, Acrobat format. Okay. So I think deck number is basically just a vendored dependency for handling decimals, and I will ignore it. And we didn't open main, and that was on purpose. But let's open main now. I think I read on Wikipedia or something before starting that JQ was originally written in Haskell and then ported to C. Which is not surprising since Haskell's used in a lot of Parsing kind of libraries. All right, here's main.c. I want to just see, is it worth looking at more? And we get a pretty interesting main loop, it looks like. Lots of if-defs for things like Win32. Maybe that's mainly just multi-platform support. And option parsing. Things like sort keys, etc. Some fixed meat comments. Is fatty. Oh, is ATTY. That's separate. It's different from being fatty. Okay. Yeah, I mean, main is maybe pretty interesting. In fact, let's look at it, but I think I want to look at it in Emacs because I don't like this. I'm not really feeling this GitHub format. So first of all, how many lines do we have? Like 772. That's not a whole lot. A bunch of them are includes, and we're mostly including, as you might expect, because this is a pretty lightweight program, but mostly including like system libraries, except a few of our own, it looks like. And we have the JQ test suite. I'm not sure what we're doing with that. I guess that's it for running tests, maybe from main. And a usage doc string, basically, with that usefully covers the command line options. And let's take a look at a few of these because we're going to see their implementation in about a second. Not a literal second, but a figurative second. All right. Null input, raw input. Read each line as a string instead of JSON. I don't really know what that means, but maybe we will see in the implementation. Slurp is read all lines into an array and use it as the single input value. I don't know if that performs better on smaller samples or larger samples or what. And then you have things like compact output, raw output, like output strings without escapes and quotes and stuff like that. Sort keys of each object on output. So I guess that's to give, I don't know how often you would care about that, but that could be used, for example, programmatically if you wanted to ensure that that every time you run the program, you get the same result. So like maybe for tests or for whatever reason, we can color our output, etc. Okay, so those are some of the options. Is optish? I don't know what optish is, and is option. And then we have this die function that I guess we just call when we die, and it's going to print out some stuff and exit too. So is option is presumably going to check whether a thing is a valid option. And this looks like just kind of like homegrown option parsing. And then we have some CB stuff that looks like it's probably callbacks, like debug callback. All right, and then we have this big process function, which is maybe going to be the heart of it, but we'll see. Although I've missed some stuff like enums. Those enums might be important. Okay, so enums. So this enum is just seems to be the option stuff, whether to run tests, slurp, etc. And then we have here, these look like kind of like error conditions. So okay, system error, which is like a 500 for HTTP, compile error, which I'm going to guess is like considered a user error if they, assuming they trust their compiler. Okay, but no output. Maybe that means that you basically input a version of the empty string and then some unknown error. And then process is going to take a JQ state, which I'm going to guess is kind of like this, the heart struct or something. Here, now we know that JV is a value, a JSON value, some flags, and the flags are an int. So I'm going to guess these are basically bit flags. And then whatever dump opt is, maybe for output, and then options. So the default return value is JQ, okay, no output, and I suppose we're probably going to override it to JQ, okay, if there is output. And then we'll call JQ start, which will presumably set some stuff up, and then we will, I guess, allocate a result. And then while JV is valid, so we're going to take this JV is valid function and pass it this result variable, which we're getting by calling JQ next on this JQ state object. So that tells us a few things. One is that JQ start is interesting, JV is valid is interesting, and JQ next is interesting. So JQ next is presumably going to like walk down the parse tree or something like that. JQ start is going to do whatever, maybe like the lexing and all that stuff. And we check some options. If we're doing raw output, for example, and the kind is a result, the kind of the result is a string, then if we're doing ASCII output, and you notice we're ANDing these enums with the options, which makes sense because options is also an int. So this is like a bit thingamajiggy, just like flags is. Then we're going to call JV dumpif on JV copy result as, I guess, to standard out in this like flag JV print ASCII. So JV dumpif must be basically do this to the output, basically printf the output. I guess we're copying the result. Why? I'm not sure, but I guess we don't want to pass it the raw result. All right, so then we have a bunch of other if statements. We have these things like JV free, et cetera, et cetera. So I'm going to move along. We also get a copy to JV dump. So I guess JV dumpif is dump f in the same sense that, in the same way that printf has an f, which is that f stands for format. And then here we set JQ, so we set the return value to JQ OK, which we had speculated, since if we're in this place, then we have some output. So that's, and then we have this check to see whether JQ halted on the thing. And if so, then we get some exit code. And we if it's okay, then we say we're okay. Otherwise, we might get some other exit code, and I guess we classify it. And then we may have some error, and then et cetera. And then what else do we have in main? We have wmain, and it's got this wide card to multi-byte stuff. I'm not really sure what that's about. And then we have regular main. Are we in an if def? Okay, so if we're in Win32, we get this umain and wmain stuff. Otherwise, I guess we just get regular main. And we set JQ state to null. And we set the input state to null, and the return is no output. Oh, okay, no output as it was above. And then we have some basically bools. Actually, this seems like maybe essentially a bool that says whether it's compiled or not. And then we have the parser flags, the number of files. I guess maybe you can call it on files. I've always seen it used on standard in. And then the last result, -1 means no result, or 0 is null or false, or 1 is true. And then bad write, which I'm going to guess is being basically used as a Boolean as well. And then options is set to 0, and I suppose that will be populated in the option parsing logic we saw above. Okay, so then we have this JSON value args is set to JV array, whatever positional arguments is, and then program arguments. Maybe we're using the stuff passed into the Unix arguments. We're maybe treating them as JSON values, perhaps. I don't know what's going on here. At any rate, we call JQ init. And wait, did we call JQ init above? What was it, process? You know. We call JQ start. Okay, so JQ init is somehow different from JQ start. And then if JQ is still null after we init, then we have some error, some system error. I guess that's somehow the JQ author is messed up, essentially. I think is what that's supposed to mean. And then we set some dump options. We set this program thing to 0, and then we do some sort of input init, initialize input, I guess. And then we have some arguments, like further args are strings, further args are JSON, etc. And maybe you can pass JSON in as an argument. And maybe that's what some of the stuff above was. I'm not familiar enough with JQ. At any rate, we're going to iterate over the args. And maybe that's just because the JSON is part of the, well, I don't know. And do some stuff with it. So if not program, then program is equal to argv1, argv of I guess that's the name of this should happen with the initial argument, I think. And then if further args are strings, then we're going to JV array append the args by taking whatever was passed in, I guess, like from the function call-y thing. I'm thinking of this as Linux, but this is also the code that runs in on Windows as well. But we're taking them in like converting them to JV strings and appending them into this args thing. And then there may be JSON arguments, I guess, after the string arguments, and then we just need to JV parse them instead of like turning strings into JSON. And so now everything is JSON. All right, and then we do a bunch of more argument parsing. Okay, so I'll leave that there. That's enough of. So we'll see where do we call process. So we call here if option provide null. I don't know what provide null is. But let's maybe look at the first call to process. Yeah, it's here. I'm not really sure what provide null is, but we may call it process with JQ and JV null. Otherwise, we're going to create this value, and while the input error state is 0, I guess basically while we have no errors, and while JV is valid, we're going to get the JQ till input next input on input state, or JV invalid has message. Then if JV is valid of value, then we call process on JV. We call process on JQ with the value and the flags. So what was the value doing here? So we called JQ start with the value here, and then we had this loop where we called JQ next on the JQ. So where else did we use value? So let's try narrowing to this function. What? And let's do occur value. So value sometimes appears as the part of a function call, like here, 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 and here. So basically everywhere except when we call JQ start, it looks like. So I don't really know why, I guess I don't understand yet why we have the outer loop that calls process with a value, and then this inner loop is also a loop, but we only really use the value in the first line, it looks like. So maybe let's take a look at JQ start. Here's JQ start in execute.c. So we've got a no mem handler, I guess, for if we don't have mem, presumably memory, and we pass it in the JQ and the value and some flags. And we're calling no mem handler on JQ no mem handler. I guess so. You will configure your no mem handler in this object, and we're, I guess, setting it here somehow. And we're passing it the data. And then we're calling JQ reset on the state. And then we've got this struct closure top, which we're going to set to JQ BC. BC what? I'm not sure. And then we have -1. So to find out what that is, take a look at the JQ state struct. So here's a JQ state struct. We're type defing JQ state to JQ state, right? I don't know what that I don't know what that means. The type def a thing to itself. Let's see if this is anything any more informative. Okay, yeah. All right, so JQ state has a no mem handler, which is a void star, or rather, so wait, what? This is a oh, it's a void star, I guess, cast as a no mem handler star is maybe what that syntax is. And then we have some no mem handler data and bytecode. Okay, so BC is bytecode. All right, and then whoa. Why are these mirroring each other? Okay. And then what else do we have? Well, we might as well look at what else we have in JQ state. We have a JQ message callback, an error, some error callback data, an error, and a stack, which has a current frame, stack top. We keep a pointer to the top of the stack, and then a fork top, I guess for forking. And then we have a JV path. Presumably that's like the path, like where we are in the JSON object. And then we have the value at the path, and these are both JSON values. And then we have an int sub-expression nest. Maybe that's how deep we are in a sub-expression. An int that seems to be basically a Boolean about whether we have debug enabled. And we have whatever initial execution is, maybe whether this is the first time we're executing. And then we have next label, which is an unsigned, which I don't know what, I don't think we've seen any label yet, but this is somehow pointing to the next thing. And then an int on whether we've halted, what the exit code is, if there are any error messages, and then input callback and input callback data, etc. So this is like the top level thing. Yeah. And then we have, so let's also look at Closure. Closure has some bytecode. So I guess JQ maybe has its own bytecode. So I didn't look at I didn't open the bytecode file in GitHub, but maybe that's worth taking a quick look at. And then we have a stack pointer, which says JQ stack address of closed frame. And then we have this, we have a frame struct, which has some bytecode, the environment stack address of frame to return to. So we know, as we add frames, we keep a thing that, once we're done executing our stuff, we're going to hand it back to the people that we're supposed to return it to. And then some return data and a return address. And a frame size and stuff. And yeah, so we've got a bunch of stuff for frame pushing, frame popping. This all looks pretty interesting. Stack save. This is probably, so this is like, this is really small. So we looked at TinyCC recently, and that to me was kind of complicated to look at because the way that they had done the logic, it was kind of spaghettified out. And this seems like a really clean implementation of a thing that has stacks and does execution. So I think that maybe this would be, if you wanted to learn about this sort of thing, then I think that this would be a good repo to take a closer look at. I am finding that I'm having an even harder time than I thought I would with all the sickness. So let me, I'm not going to spend too much longer on these details. I do want to see a couple of more things, like I'd like to at least see the parser. So parser.y, I'm not sure, I'm not positive that this is Yak, but maybe. So we've got this like mustache template thing. This is obviously C. YY Malik. Let's see if we can find YY Malik. Yeah, it seems like this seems like it's probably is yak. All right. So we whatever yak is up to, we've got things like defines. Oh, I thought yeah, it is malloc. Okay. If n loc start yy, I don't know what any of this stuff is, but this is obviously tokens. So we've got tokens like invalid character, these literals like ident, field, binding, literal, format, and then things like equality. Equality looks like double equals. Set mod. This is like you're taking the modulus and also assigning the variable on the left to the variable on the right. I assume rec is maybe record record access, accessing the member or like a sub record of a record. Define door. Defined or. I'm not sure what this is doing, but these are obviously the tokens of the of like the language of JQ. And then however yak works, we're defining like all of the stuff we would need to create a parser, and then we have yylex. This is yeah, so yak is the parser generator. I thought what is bison? GNU bison is a parser generator. I guess similar to yak. So those are not. So I thought Lex was a separate thing, and so maybe it is, but I guess it somehow works with yak. Let's see if yylex is a thing. Yylex returns a value indicating the type of token that has been obtained. Okay, so at any rate, this is essentially like the I guess you would call the grammar for defining the parser. And then we have parser.h. It says a Bison parser made by GNU Bison. Bison interface for yak-like parsers in C. So this may be the generated code based on the .y file. And we notice, for example, a bunch of the same tokens. So I'm going to guess that this is perhaps the generated code. And then here's parser.c. Let's ask ChatGPT. Tell me about how GNU Bison works. Does it generate C code from a description of I'll say from the .y file, which means it takes a formal grammar description of a language and generates a parser. So you write the grammar. You start by writing a formal grammar for your language using the Bison grammar in a .y file. Yeah, that's what we did. Not we, the JQ people. And then once you've written the grammar, you run Bison on the .y file. Bison reads the grammar specification, generates a parser in C or C++. And then you compile the parser. Okay, so I think that this is the compiled code. And then we have, and then we have a list, an opcode list. And I don't know how this is different from, maybe the bytecode is a series or sequence of opcodes or somehow combinations of opcodes. But the opcodes are things like dupe, I guess like duplicate the thing on the stack. So this may be, is this like a stack-based language? JQ language. Let's see if we can find much about it. It's a very high-level, lexically scoped functional programming language in which every JSON value is a constant. Okay, so everything is a constant. All the JSON, it supports backtracking and managing indefinitely long streams of JSON data. It is related to Icon and Haskell programming languages. Okay. I forget what lexical scope is. Oh, okay, as opposed to dynamical scope. The use of local variables. of variable names with limited scope, blah, 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 blah. In lexical scope, also called static scope or static scoping, if a variable's name's scope is a certain function, then its scope is the program text of the function definition. Within that text, the variable name exists and is bound to the variable's value. But outside that text, the variable name does not exist. In contrast, dynamic scope, if a variable's name's scope is a certain function, then its scope is the time period during which the function is executing. Yeah, which I think is how Emacs does it, right? Examples of language that use dynamic scope include Logo, Emacs, Lisp, LaTeX, and shell languages Bash, Dash, and PowerShell. Okay. But that doesn't really tell me what I... At any rate, so we've got these opcodes. So we can dupe, I assume, is like duplicate, dupe2. I'm not sure. Some variant of duplication that has a 2 in it. I don't know if we're duplicating things 2 down or duplicating something twice. We can pop something off the stack. We can load v, store, etc. So that looks to me a little bit like a kind of like a similar to Forth, like stack-based opcode stuff. But while we're at opcodes, let's look at bytecodes. So we're defining this at least referring to this opcode thing here, and we have an enum. Op has constant, op has variable, op has branch, and has a cfunc or a ufunc. Cfunc and ufunc, I'm not sure what those are about. Opcall is pseudo. I don't know what that means, and opcall has binding. And then we have some, I guess, opcode descriptions. Maybe for like decompiling and making a readable version of whatever's supposed to be going on in the opcode. And then we have a symbol table, which has some C functions and some NC functions and some cfunc names, etc. And then we can dump disassembly, which lends credence to my theory that disassembling was what opcode description was for. Okay, so that's just a quick look at opcode, at bytecode. We'll plow along. So here's linker.h. We've got this load program, which is going to take this JQ state and a source with this loc file struct. I'm guessing this is essentially a line into the source code, perhaps the source code being just the JSON. And then we have an output block. And then we have this load module meta. So we saw, I think on Wikipedia just now that JQ as a language has modules. But I'm not really sure what linking is going to be doing here. But let's see if this tells us. So load library. I guess this is maybe for extending JQ possibly. So we see if the path is relative. And given a lib path to search first creates a chain of search paths in the following order. We have lib path and the -l paths passed into the command line. And then we have this build lib search chain. And it's going to take a JQ state, a JV search path. I guess everything is just a JV, so that's not so, maybe it's not supposed to be so interesting that they're JVs. But we have a search path, an origin, and a lib origin. Let's look up JQ modules. Various JQ modules. So we can call JQ include CFSG graph, semicolon, graph prime, template.json. Then we pipe that into JQF dot. And we pipe that into dot. This, I guess, dot's going to render some graph. And I don't know what template JSON is. The script produces a JSON graph representation of the security rules found in a given CloudFormation template. So I guess template.json is like the input you're passing in. And whatever, I don't know what graph prime is supposed to be, but somehow that's telling, we're extending the functionality of JQ by adding this CloudFormation graph thingamajiggy, and then calling it on the thing, and then doing some post-processing. So I guess that's how you do modules. Okay, and then we have this lexer.l statement. I'm assuming this is a lex file. The syntax is very similar to the yak syntax, and this will be for lexing. So if we see this um, uh, string, I guess, this combination of characters, then we will convert that into the NEQ. I think this is probably some enum, but this is like a machine understandable thing, and this is like a human understandable thing, and this is the bit that translates between them. And then here's lexer.h and lexer.c. I'm going to guess are the generated files from Lex. And then we have JV thread. JV I'm going to get is just the we know that is now is just the value, and I'm assuming this is. I don't know what I would guess, but maybe for long enough JSON, it makes sense to parse it in parallel somehow, or perhaps this is more for modules. But we're doing some semaphore handling. We're using p threads, and we've got some p thread mutex lock, and but what are we doing? Let's look at thread.c. Do we have thread.c? No. But let's see if we can find JV thread used in anywhere. So we use it in D2A TSD and JV.c. We've got some TLS keys. This is an implementation of thread-specific storage with destructors. Copied from Heimdall, thread-specific keys. Okay, but why? And we've got this D2A stuff. Pthread key create. Key lookup. I'm not sure. Let's look at JQ threads. Load a large JSON file using multi. Try to load a large 3 GB JSON file. 3 gigabytes of JSON. Why? Currently with JQ utility, I can load the entire file in nearly 40 minutes. Now I want to know how I can use parallelism / multi-threading approach in JQ in order to complete the process in less amount of time. So we're calling jq.exe, I guess, on Windows with this huge thing. I mean, this is not 3 gigabytes. And you get some data back. You're not going to achieve this using JQ alone. Here is a streaming approach which assumes your 3 gigabyte data is in data.json. And here's the filter. We're going to select whatever length equals 2 as the P and V, whatever this is doing, setting R maybe to P, the thing at P1. And if P from 2 to 6 is body, party, general info, then dot name equals something that I can't see. I guess just just V. Else if it's this other thing and P7 ID, then dot ID equals V, else empty. And then you, I guess, run JQ with stream F filter 1.jq data.json, which will produce a stream of results with minimum details you need. What? Okay, so I'll ask, why does JQ have threading support? Threading support enables JQ to process JSON data concurrently, splitting the workload, blah, blah, blah. Okay, so explain how it uses threads. It doesn't inherently support threading. It's primarily a single-threaded tool. However, so does JQ support using multiple threads? So both AIs are saying no. So I'll say, does JQ have a dependency on pthread? Yeah, I really don't know. I'm curious to know more. But JV mem free. So maybe you can see like one of the specific calls to the threading stuff is doing. Why are there TLS keys? I'm not sure. Maybe I just don't know. Let's take a look at jv.h. So we have this enum that says whether the kind is invalid, null, true, false. It's a number, a string. These are like the JSON types, I guess. Array, object. All of the fields of the struct are private. Really, do not play with them. So you have kind flags, pad, offset, etc., etc. That's some sort of internal bookkeeping stuff. Things are like a union of a either a JV ref count or a number. All JV star functions consume decref input and produce incref output, except JV copy. Okay, so there's some reference counting stuff going on here. We have a bunch of arrays, like JV array 5 is a length 5 array, presumably. A JV string slice is a thing that has a value and a start and an end. So that's going to be the slice indicated by start and end, and so on and so forth. JV object merge recursive, I'm going to guess is like, we haven't merged these two yet, but this is like the record of the intent that that's what we want to do. Hello, cakes. Huh. I told this window to be on top, but it's not working. But hello. Okay, and then we've got more. So we've got some like JV object stuff that is like, this is a 16 size tuple object, I guess. And then we've got some flags, like whether the pretty print, whether to sort, color is an attribute, whatever space 1, space 0, and space 2 are. But I still don't see anything about threads. Huh. Maybe the threads are for compiling. Find pthread if we have it. We do this first because we may set pthread on cflags, which can cause various macros to be defined. I'm wondering if the threads are really for the build system. Although we have this pthread once. Pthread once init, D2A context once. So this is like initializing this context and making sure that we only do it, I guess, once per pthread. Why is it so hard or expensive to initialize this context? I'm not sure. TSD D2A context get. So pthread once of the context once. Whatever TSD, I'm not sure what TSD is. And then we're getting some key from pthread, the D2A context key. And if we don't get it, then we're going to, I guess, malloc a D2A context struct, etc. So it does seem like we're doing, that we're possibly parsing stuff in parallel. Let's just look up D2A TSD. JQ. To number loss. I believe JQ has its own D2A in order to produce Stedalon's preferred output representation or something like that. We'd have to ask Stedalon. Okay. Processing TSV embedded with JSON in our, I don't know. Is TSV tab separated value file? No idea. Maybe we can find, maybe we can look at blame. Save literal values of the blah, blah, blah. Fix Windows build. Yeah, I don't know. This seems to be adding a new, so the JV thread.h file seems to have been added in the commit to fix the Windows build. And relatedly, although pthread is used here, JV thread.h, this doesn't seem to come from moving something else. So this references the Windows build, and that I think is consistent with my theory that the threading is about the build system, building JQ in parallel rather than parsing JSON in parallel. That's going to be my working assumption. At any rate, here's JV parse, and we've got some stuff like last seen, last open array, and then we have this parser struct, which has got a current buffer, some metadata about the current buffer, like its length, position, whether it's partial, bomb strip position. I don't know what a bomb strip is, but some position. We keep track of the flags. We've got a stack, which is like a list of JVs. We have stack position, where we are in the position, the length of the stack, the path, which it says is a streamer. I guess I don't know what a streamer is. Presumably somehow it's going to stream some stuff. Last seen is also a streamer, and output. So on the chat, Hadi Mohammadi says, I cannot read source codes. I don't know why. I think I don't understand a thing from a software source. Well, I mean, I think it's just like a different, it's a different thing than writing the source, I think. And that's, I think that's totally normal to feel that way, at least at first. But you eventually get used to it. And obviously, obviously you're not going to understand everything that you read, especially the wider the gap between what you're looking at and what you're already familiar with, the harder a time you're going to have. All right. So on the parser, we've got stuff like the stack position, and next, which I think we already saw some of. And then parser init is going to take this JV parser struct and some flags and set the stack to 0, set the stack length to and the stack position is to 0, initialize scene to what was it, none, etc. And this is all set up, it looks like. And then we call JVP D2A context init. And I don't know why. I don't know why this library is so focused on D2A. But that's the thing. Maybe there's something crazy about JSON's numeric representation. We've got this parser reset function, which is going to presumably reset the parser state similar to init. Parser free is going to call free on things like the path and the output. in the stack. And I don't know if this is going to like walk along the stack or whether, but it's somehow going to free stuff. And then we've got this value, which is a pfunc. Maybe pfunc is parser func, but you pass it in the parser struct in the JV val. And we do things like check if it's valid. And if it's the last value, then we free val and return expected separator between values. So there's some sort of error, it looks like. And if stack length is bigger than 0, we set last seen to JV last value. Otherwise, stack length is 0, so we set it to JV last none. And else, I guess if else means we're not streaming, then we check if the JV is valid on the next thing, I guess like the next token or whatever, the next bit of JSON. We free val, and we have this expected separator. So this is another, I guess, error condition. And then if we get down here, I'm not sure why. So do we do nothing if we're not streaming? I don't know. Okay, otherwise we free the pnext thing, and then we set pnext to equal to val. So what was p? Yeah, okay, so this is just recording the fact that we've essentially seen val and it's putting it in its proper place in like the list of, or the stack of things that we've processed. Then we have push, which is presumably going to push onto the stack. And we check the stack position. If it's equal to the stack length, and I guess we're at the end, right? We set stack, then we set stack length. Okay, no, we're growing the stack. So we take the stack length, double it, and add 10. And then we make sure that we have enough memory. And then we assert that the stack position is strictly less than the stack length, at which point we index into the stack at the next position and set the next position to v. So that's pushing it onto the stack. All right, and then we have parse token. This is going to take this parser thing in a character. And we do things like, okay, so we've got a big switch statement. If the character is, so this is parsing. This is checking what kind of thing we have. Like, is it a comma? Is it a curly brace? Is it a colon? And then handling the corresponding output. Let's, I guess, look at colon, I guess. If the next thing after colon is not valid, then we say expected string key before colon. Maybe pnext is the thing we processed before, as opposed to the thing that we process next in that case. And then we check if the stack position is 0, or the kind of the stack position of the stack at stack position -1 is object. Then we say colon is not part of an object. And then if the kind of pnext is not a string, then we say object keys must be strings. So this makes it seem like we're looking at the thing after the colon, but this makes it seem like we're looking at the thing before the colon, because this is the key, and this is the object, and we are, in both cases, looking at pnext. So maybe JV is valid is somehow peeking at the stuff before as well. I'm not sure. At any rate, we push pnext onto p, and then we set pnext to JV invalid, and then break. Why do we set next to JV invalid? I'm not sure. But let's also look at curly brace. So if we're at a left curly brace, then if the stack position is bigger than or equal to the max parsing depth, we'll say we've exceeded our depth limit. If pnext is valid, then we say expect separator between values. Okay, and then other ways we push. So what is JV is valid doing? Can I go to a definition? It's going to return whether the JV kind is not equal to JV kind invalid. Okay, but we saw that we were setting things to JV kind invalid in ways that I thought was a little bit surprising. So maybe that's all that's perhaps being used as an intermediate value when we don't yet know that. I'm not sure. I'm not sure what they're doing there. At any rate, I think I'm gonna just about finish up. I'll take a look at the files we have left, but I'm not gonna, I think, spend much time on them. So auxiliary aux, I'm gonna guess is auxiliary. We've got things like JV number, get value, and consume. Parse slice, where we give it the value and the slice thing, which has a start and an end. And we have like array slices, etc. And this seems to just be like kind of like helper methods: set, get, has, whatever dells is, maybe like delete, compare. So this seems like maybe like just helper methods. So JV alloc is things for like allocating memory for the JSON values. Exec stack, the stack is a directed forest of variable sized blocks. A directed forest, so we could have multiple roots. Each block has a next block, which is at a higher memory address. Oops. Or 0 if the block has no next block. More than one block may have no next block. A block may be the next block of more than one other block. Pushed blocks are added at the low address end of the stack. Stack pointers are negative integers that are offsets relative to the mem end, the end of the allocated region. The stack bound is the stack pointer of the last block that would be able to fit in the currently allocated region. The stack limit is the stack pointer of the last block currently in the stack. The stack pointer of the next block is stored directly below. So here's memory end, and then we're going to grow down. So stack pointer is negative 0x18, then next equals 0. Stack pointer 2 equals limit equals negative 0x40, and then next equals negative 0x negative 18, which is here. And this is, I'm going to guess, like a companion file to the execute file, which we saw briefly, but I don't think we took a close look at. Here's compile.h. This is doing stuff with blocks, and presumably it's going to be kind of like the interface to the stacky system. We've got some no ops. We generate op target, generate op unbound. I don't know what unbound is. Bound might refer to the stack bound, but these are like generating the opcodes, I guess. So we're compiling whatever JSON we have to the opcodes. And we've got this module stuff. We can generate a function and a lambda and some other stuff. But I don't have a whole lot of time to go into it, and I'm gonna stop there. So that was actually a really cool project. I thought that would be pretty small. It's not a whole lot of files, but it is. It's like, well, it looks very well put together and pretty self-contained. And I think, especially if you use JQ a lot, which I don't, then I think it seems like a good repo to look at and to learn from, especially if you don't have a lot of experience yet with compilers and that sort of thing. So I'm going to leave it there. Thanks for watching.